Chapter 5, Section 8 is graphing absolute value functions. So the most basic absolute value function, first of all, it's a function, so we're writing it as f of x equals. The most basic, the parent function for an absolute value function would be the absolute value of x. Now we're going to do some graphing with this, but you would literally just plug this into your equation. So in your calculator, you would do y equals, and then you type in the absolute value of x. In order to do that, you press the math button, you go over to NUM, which stands for numbers, and the first one says ABS, and then there's the open parentheses. You press enter on that, you insert an x inside the parentheses, and it will graph this function for you, and we can go to the table and find all of those values. Now, an absolute value function is always going to look like a V. It's always going to be that V shape. So you never want to only graph part of it, because then it's just going to look like a linear equation. You want to graph the positive and the negative x values. So you want to show that it's making that V shape. So these are our first two examples. If I'm writing them as equations, I'm writing them like this. If I'm writing them as functions, it would be f of x. But for our purposes, we're going to do them in the calculator, so we're going to talk about absolute value equations. So in your calculator, you're typing in absolute value of x plus 2 and the absolute value of x minus 2. We're going to create a table for each of these. Since they're non-linear, we need at least 5 points. You either need to have a table or label the points. Here I labeled the points, but just so that you could see how you would organize it in a table, my x values are -2, -1, 0, 1, and 2 for both of these graphs, just so that we can compare them to each other. And you can see that my y values are 4, 3, 2, 3, 4 in the first, and 0, -1, -2, -1, and 0 in the second. I need to label with my equation both of these. So y equals the absolute value of x minus 2, y equals the absolute value of x plus 2, and make sure that you have an interval on both graphs, arrows, label your axes on both graphs. Now the absolute value parent function would be at 0, 0, so it would be here. You can see that when you add 2 outside of the absolute value symbol, it shifts the graph up, it translates it, it slides the graph 2 units up. Whereas if you subtract 2 from the parent function, it slides it, it translates the whole V shape 2 units down. Make sure you have both graphs on graph paper in your notes with tables, or you label the points. So to translate y equals the absolute value of x 2 units to the right and 2 units to the left on a separate graph. So up and down you add or subtract outside. When you subtract inside the absolute value bracket, that actually moves it right. So in this case, x minus 2 shifts it to the red line, which you can see is 2 units right, and x plus 2 shifts it to the left. So when it's inside the brackets, plus moves it to the left, minus moves it to the right. Make sure you understand that. Outside of the brackets moves it up and down, so plus is up, minus is down. Inside of the brackets, it's kind of the opposite. Minus moves it right, plus moves it left. Now you can think of an absolute value function as an example of a piecewise function. A piecewise function is a function that gives you different definitions for different values. So a piecewise function would be written as something like this. So in this case, this can be thought of as a piecewise function. It would be the equation x plus 2 when the x value is greater than or equal to 0, and it would be negative x plus 2 when the x value is less than or equal to 0. So less than or equal to means you close that circle. So both of them are or equal to, so that's why it's a closed circle here. And what this means is for every x that's greater than or equal to 0, so all of these values, you graph this linear equation, x plus 2. And wherever x is less than or equal to 0, you graph this linear equation for all of the values that are less than or equal to 0, and it's a piecewise function. So that's one way that you can think of absolute value. And keep in mind this is when x is less than or equal to 0, and this is when x is less than or equal to 0. So the slope is -1 on one side and +1 on the other side. Finally, we have step functions. So copy down this word problem. A school will charter buses so that the student body can attend a football game. Each bus holds a maximum of 60 students, so maximum of 60 students. Make a graph that models the relationship between the number of students, x, so we label our x-axis number of students, that go to the game by bus, and the number of buses, y, that are needed, so we label our y-axis number of buses. We also have our arrows, and we labeled x and y, so everyone should have that. We also need some sort of title, so school charter buses. Something along these lines. Now, this next part tells us that we will need 0 buses for 0 students. Well, that makes sense. 0 buses for 0 students, you plot your point there. As the number of students increases, the number of buses goes up by 1 every time the number of students exceeds a multiple of 60, because each bus holds a maximum of 60. So, obviously, when there's no students, there's no buses. So that's why we have an open circle here, because it's not including that. But for every 1 student all the way up to 60, there's 1 bus. So we have a line and a closed circle at 60. Then starting at 60, we don't need 2 buses yet, so we put an open circle. But at 61, 62, 63, 64 students needs to have 2 buses. So anywhere from 1 to 60, you need 1 bus. Anywhere from 61 to 120, you need 2 buses. Anywhere from 121 to 180, we need 3 buses. And we know that when there's 0 students, we need 0 buses. So that's why there's these steps instead of just a linear equation for 1 through 60. So when x is 1 through 60, it's 1 bus. For 61 through 120, including 120, that's why there's a closed circle here, but not including 60, that's why there's an open circle. And the same thing goes all the way up. We will do a few examples of these in class, but read through this example again and understand why there's a horizontal line for 1 through 60, horizontal line for 61 through 120, horizontal line for 121 through 180, and so on. And make sure, because it's a word problem, we have all of our labels and titles that we need.